Today we are going to be learning about gears, pulley drives, and sprockets. This is located in 1.1.3. So first off, we got to talk about what is gears, pulleys, and sprockets. These are ways of transferring power from one element to another. For instance, transferring energy from a motor in your car to your tire of your car. Now they have various different methods of doing that. They can use pulleys, located, you can see here. You have sprockets and chains, that's like in your motorcycle or your bike, or you can have a traditional gear system. Now I want to emphasize, this is not a mechanical advantage. They do not cause gears, pulleys, and sprockets do not create mechanical advantage. They only change speed of rotation, the direction of rotation, and the amount of torque. Gears are simply a way of transferring that rotational motion or torque through interlocking teeth. Gears are meshed together. The driver gear is the one that's given the energy, and then you have the driven gear is the one that's receiving that energy. So you can think of the driver gear as the engine, while the driven gear is the gears in your wheels. Now, when you mate the gears together, they are always opposites to each other. So you can look at here and they're always going to rotate opposite. An idle gear is one in between the two, the driver and the driven. And this red one here, this is your idle gear. It does not play anything within the math or any of that. All it does is it just changes the direction so that both the driver and driven are going in the same direction. It's actually a fun little test. You just draw a bunch of circles all connected at the edges, and then you just say from here to this other circle, what are the directions? Are they opposite or the same? It's a fun little game you can play. Mating gears always have the same teeth, or we call diametric pitch. We're not going to talk about the math of that, but there is a whole level of math talking about making sure that the teeth work together. Now the RPM of the larger gear, yellow here in this case, is always slower than the rotation of the red gear. If they are locked together in the same axle, the same shaft, they will have the same RPM and same direction. Now let's talk about gear ratios. Gear ratios, we can use either the number of teeth, the diameter, the angular velocity, we call that omega, that's what this symbol is, the W, or the torque. So in this case, we have our blue gear has a total of 12 teeth, our red gear has 6 teeth. The diameter tells us up here is 2 inches versus 4 inches. Then its rotation. This is 40 RPMs, so going around 40 revolutions per minute, compared to the 20 revolutions per minute. And again, lastly, the torque in, torque out, 80 foot-pounds compared to the 40 foot-pounds of torque. Now, here's what makes real life really simple. The equations are all equal to each other. The gear ratio is teeth out over teeth in, diameter out over diameter in, omega out over omega in, or torque out over torque in. So they're all out over in, out over in, out over in, with the exception of omega, the funny omega symbol here. This one's in over out. So just remember, omega's weird. The revolutions, the RPMs, is backwards. So in this case, we can look at it, teeth, so we can look at it 12 teeth over 6 teeth. Diameter is 4 over 2. RPMs is 40 over 20, or 80 foot-pounds over 40 foot-pounds. So any one of those fractions can give us the gear ratio of 2 to 1. So, what are the gear ratios in this case? Looking at the gear ratio of A to B, blue to green, is going to be 12 over 20, or 0.6. What is the gear ratio from B to C? That's correct, 5 over 12, or 0.42. What is the gear ratio between C to D? That is correct. 20 over 5 or 4. Now, when you have a total gears train ratio, so looking at the idle gears, let's say B and C, so you have A driving, D is your output, input here. B and C don't matter. They don't count. So we can look at the total gear ratio of just A to D. And if you notice, gear A and gear D both have the same amount of teeth, same diameter, same everything, so they're going to have a gear ratio of that. So if we were to have them connected this way, all we do is we just multiply all of the other gears, A to B, B to C, and C to D, and multiply those all those fractions together, and that would give us, in this case, 1, a gear ratio of 1. So here it is, 0.6 times 0.42 times 8 times is equal to 2, and you get that ratio. Now, gear ratios look just similar, have the same math as mechanical advantage. Force out is just mechanical advantage times force in. Torque out is equal to gear ratio torque in. So we can use that formula to calculate the torque out. Mechanical advantage is just the products of all of the mechanical advantage. Gear ratio is just the multiplication of all the gear ratios. So they're just used in the same manner. There's no change. So let's go for an example here. Here are 3 mechanisms in series: a wheel, an axle, another wheel and axle, and then we have this gear train right here, the fuchsia and blue. What I want to know is, what is the mechanical advantage of the first gear, wheel and axle? All right, 2.67, good. Now we're going to look at what is the gear train. What is the gear ratio, again not mechanical advantage, but gear ratio between the fuchsia and the blue gear? All right, that's 0.42, good. So lastly is, what is the gear ratio, or the mechanical advantage of the blue gear? All right, lastly it was again 0.15. All right, so now we can just take our 2 mechanical advantages, our 2.67 and our 0.15, and that gives me a total of 0.4. So its total gear ratio is there is no other gears involved, so it's just 0.4. So we have a driver driving on a yellow. Notice how green is going faster than yellow. But this time we're going to stick blue onto yellow. Notice how they're going at the same rate of revolutions, the same omega or the same RPMs. And then lastly we're going to put red there. This is called a gear train. The 2 middle gears share a common axle, so they're going to rotate at the same speed. This allows for the final gear to rotate slower and produce more torque than if it were connected only to the drivetrain. So if you have just gear after gear after gear in one long continuous line, that's not going to really help. But if you put this gear train here connected with a mechanical advantage here, with a wheel driving axle, that's going to slow down even exponentially more. So what is the gear ratio between A to B? A to B is going to be your 40 over 10. What's the gear ratios of C to D? Well, I look at C, that's 50, or D, that's 50, C is 20, again 2.5. What's the gear ratio of the entire gear train? Well, you multiply those two together, and that gives you a total of 10. Now we're going to move on to belts and pulleys. Belts and pulleys are exact same math. The only thing is belts and pulleys don't have teeth, so you just can't use the teeth. But everything else is the same. The gear ratio, or I guess the ratio, would just be the same equations: diameter out over diameter in, omega out and torque out over torque in. Notice that again, your omegas are flipped. So in this case, the scenario, diameter out 6 over 2, 30 revolutions over 10, notice that's again flipped, or torque 55 foot-pounds over 18.3 foot-pounds. Sprockets are the exact same thing, but this time you do have teeth, so you can add teeth into that, and it does the exact same thing. 22 teeth over 11 teeth, diameter 3 inches over 1.5, omega 90 revolutions over 45 revolutions, and then lastly your torque, which is 120 over 60. Sprockets and chains happen to look just like your pulleys. Now, comparing pulleys and sprockets, the reason you want to use pulleys they're frictionless, or not, they use friction. Pulleys use friction, and so they use a belt. Sprockets are a chain. Now, the advantages of pulleys is they're quiet, require no lubrication, and are very, very inexpensive. Compare that to sprockets but do not slip because they have those teeth, but are greater strength. Now, the disadvantages is pulleys can slip. You can hear that sometimes in some older cars when you start them up in the morning. You hear that high-pitched squeaking, screeching. That is the pulleys slipping inside your car. On the other hand, sprocket, which is in your drivetrain inside your car, if it slips, it would destroy your car. And so what they do is they have it using a sprocket and chain to keep it from never slipping, so that you would never have a misfire. But it's going to be higher cost, and it constantly needs to be lubricated, and it's very, very noisy.